Okay, so we're going to look at some questions involving straight line graphs, but just to do a quick review first. Basically, when you think of straight line graphs, then we're thinking that graphs can go in the positive gradient or they can go in the negative gradient. So that would be a positive gradient and that would be a negative gradient. And we've got to think of general things. So when I think of straight line graphs, then I'm thinking of y equals mx plus c. I'm thinking that y represents the value of the y-axis on the straight line and x is the thing. So every graph is set up through coordinates xy, and the point that it crosses the y-axis when x is 0 is known as the intercept point, and the gradient is calculated by working out the change in the y values divided by the change in the x values. So we have a formula for the gradient. So m is the gradient and it equals the change in the y values divided by the change in the x values. Now the triangle is just a mathematical way of saying change, so it's the difference in the y values. So basically we'll have chosen two coordinates on the line, and then we'll do the difference in the y coordinates and the difference in the x coordinates, divide those two and you get the gradient. And c is the intercept point and it's always at the coordinate 0c. So we must remember that c is calculated when x is worth 0, because we've got to remember that these coordinates are represented by an x value and a y value. And so the work I'm going to do is just going to go through some exam questions from before, and it'll show you various things to do with straight line graphs and coordinates, and hopefully useful for work at grade 4 and grade 5 foundation level is what I'm covering in this particular video. Okay, so it starts off fairly straightforward. We've got a graph here. They want you to write down the coordinates of the point A, so we remember that coordinate. So as soon as we see that keyword, we should be thinking we need two numbers, how far across we've gone on the x-axis and how far up or down we've gone on the y-axis. And in this case we've gone across 2 at 1, so we can see that that coordinate would be 2, 1. The question goes on and it asks you to draw on the grid the line x equals 3. So it wants you to draw the line x equals 3. Well, what we've got to remember is that when x equals 3, then every coordinate will start with 3. And it could be anywhere, so it could be at -1, -2, and so on. So plotting those points, then 3, 1, 3, -2, 3, 3, all of those points, and then we'd get our ruler and we would draw a straight line up. And that would be the line defined by x equals 3. Now if we want to do y equals 2, then of course that's telling us that every coordinate has got a 2 value, so something 2. So it could have been 3, 2, 5, 2, -1, 2. All of those coordinates would fit on that line. So 3, 2, 5, 2, 4, 2, -1, 2. So, but this time the line would be horizontal, and this line would be defined as y equals 2. So we've just got to recognise some key things about graphs and straight lines from a basic point of view. Now, if the exam question said what's the midpoint between A and B, so if we want to talk about the midpoint, of A and B, then basically we'd take the two coordinates, so we've got 2, 1, we would add them together and we've got -2, 3, and then we'd halve the value. So we want the midpoint of coordinates, then we add the two coordinates up and then we halve that value. So we add the x numbers up to give us 0, because 2 plus -2 is 0, and 1 plus 3 is 4, and then we halve that value, so we end up with 0, 2. So we can see that the coordinates for the midpoint would be on this particular graph there. And we could have done it by counting squares, but sometimes we don't get given the axes to do that, and therefore we need to remember that there is a quick formula for getting the midpoint where we add the two coordinates up and halve them. So that's a quick summary of that kind of question. This kind of question is asking us to complete the table of values for this function, and we recognise it's of the form y equals mx plus c, just being written in a slightly more awkward way. So we can see from this that our gradient would be -2. Well, that tells me that the graph is going to go in this direction, and our c value is going to be 8, which tells me that the graph is going to cross at 8. So we recognise that that's what the graph should look like. They just want us to complete some values to allow us to then draw it. So we can see on here then that to calculate this value here, we would be doing the y coordinate equals 8, take away twice the x coordinate. Now again, notice that I substitute the value of the letter in a bracket so that it can help me to think about how the negative is going to work. And we can see here then we're doing 8 take away, well, 2 lots of -1 is -2. And then we recognise that when we see taking away a negative, then it means we're going to get bigger. So therefore this becomes 8 add 2. So the answer there will be 10. And that's logical, because if we think what this graph would look like, then we know at -1 the value's got to be up here somewhere, so it's got to be bigger than 8. So again, it's a way of checking yourself as you're doing this. This has come from 8 take away 2 lots of 0, which is 8. This has come from 8 lots of 2 take away 2, which is 4. And this one's come from 8 take away 2 lots of 3, which is 2. And various things we should notice about this to make sure we have done this correctly. That straight line graphs of the form y equals mx plus c, the gradient change when you're doing a difference of 1 in the x coordinates is the same as the m value. So here we've got take away 2, here we've got take away 2, so everything's going down in 2s, which we would have expected from the gradient of -2. The question then goes on and asks you to plot those points and draw the graph, and it's saying to do it from the values from -1 to 4. So we can see that from our table we had -1, 10, then we had 0, 8, then we had 1, 6, and technically we don't need to draw any more points now, because as it's a straight line, then as we've got 3 points, they should line up and everything would work. So at 3 it was 2, and at 4 it will be 0. And again, we get our ruler and make sure we've lined up our points carefully and drawn our line through those points. And we've completed what the question wanted, because we've drawn between -1 and 4 on the x values, and we have drawn the straight line that's representing the graph. Okay, so just remember, when it says draw a graph, it does mean not just plot the points, it means draw the actual graph. Okay, so that's one example. We've got another example here where this exam question asks us to draw the graph of y equals 2x take away 3 from -2 to 2. They've given us no table to fill in this time, and this is classic of the new exams, that they'll just tell you to do something and expect you to recognise that you'd need coordinates. So draw is telling us we need coordinates, and this is telling us what function to use. So we recognise that we need some coordinates, and because they want us to go from -2 to 2, then I'm going to go -2, 0, 2. You only need 3 points to plot a straight line, and all equations of the form y equals mx plus c, gradient times the x value plus a number, where that number could be negative, of course, in this case. You just need 3 points to plot them. So again, just to remind you, we do twice the x value, and then we take away 3, substituting again by putting a bracket for the letter and then put the number inside the bracket. So we've got 2 lots of -2, which is -4. We're taking away 3, which means we get to -7. Just got to remember that on the number line, we know that if we was at -4, take away means we get even smaller, and therefore we'd be taking away 3 and counting down to -7. So that's going to be -7. When we put 0 in, then we're doing 2 lots of 0, take away 3, which is going to be -3. And when we put 2 in, we're going 2 lots of 2, take away 3, which is 4, take away 3, 1. So we recognise that that will be 1. So that gives us our coordinates, and because they're paired up, then this has given us the coordinate -2, -7. This has given us the coordinate 0, 3. This has given us the coordinate 2, 1. Remembering that all coordinates are x value first, y value second. And then just the classic thing, we just get the graph paper and we plot those points. So the first coordinate was -2, -7. The next coordinate was 0, -3. And the next coordinate was 2, 1. And if we calculate those correctly, then we should see that when we get our ruler, then we plot those values and they should all line up and we've got the graph drawn. It did say to do it from -2 to +2, and that's what we've done. We've made sure we've used the values from -2 to +2. So that's what the answer to that particular question would be, and we'd label it. So this is y equals 2x take away 3. Now, a check in our mind is we know that this graph should go through -3, and it's a positive gradient because the 2 is telling us that the gradient is worth 2, and therefore we know it's going to go in that direction through -3 when x is worth 0. So that's our kind of check to make sure we've done it correctly. Now this next question is doing straight lines, but it's doing it in a slightly more awkward way. It's telling us that we've got a relationship between height and width, and it's telling us they're in the ratio of 9 to 16. So in other words, x divided by y is the same as 9 over 16. So that's what this is basically telling us, and then we just rearrange this to get y equals. So we can see that if we bring the y across here by timesing, then we end up with x is equal to 9y over 16, and then we would bring the 16 across, so we end up with 16x is equal to 9y. And then we divide by 9 because we want to know the y value. So y equals 16/9 of x. So we know that's one way of doing that question. Because we need some coordinates, then we could give x values and then calculate that by doing that multiplication. Another way of thinking about this is that it's talking about x to y is 9 to 16. Well, we've been given a graph that goes from x values of 20 to 80. So I could put in some x values that make sense. So I want to be doing multiples of 9. So multiples of 9, so I could do 27. And then that means the y value would be 48. I could do 45. And that means the x value, the y value will be 80. Again, we recognise that equivalent ratios mean that we can times by 5, and that's why we get that. And then I could do a slightly higher value, so we get 3 values going across the graph. So I've times 9 by 8, so I'm going to do 8 times 16, 80, 128. So I've now got 3 sets of values where I could have put the x value in and then times by 16 over 9, and that'll give me the y value, or I can do it by equivalent ratios, and these will give me coordinates. So for example, this one has given me a coordinate of 72, 128. Now when you're doing real life graphs and straight lines, then we need to remember that you should always think of the scale. So we can see on this graph that for 10 little squares up here we're going up to 20. So in the vertical, 1 square is worth 2. In the horizontal we can see that 10 squares is worth 10. So 1 square is worth 1. So the idea now is that we then plot these values, and so we've got 2748, so 2748, so 25, 26, 27, 42, 44, 46, 48. We've got 45, 80, and then we've got 72, 128. So 72, 120, 2, 4, 6, 8. And again, if we've done that correctly, then all these 3 values should line up to allow us to draw the straight line. Again, it's really important to remember that that's a key way of doing these, so you need 3 points. Now it's a real life graph, so we draw across the whole graph paper. So that's given us our graph, so that's allowed us to calculate what's going on with that. Now the question went on and said a TV has a width of 90, use your graph to work out the height. So a TV has a width of 90, so we find 90 on here, so that was 90, and we come across and we come down, and we can see that was 50. Okay, so the answer to this question, so it said at a width of 90, use your graph to find out the height of this TV. So we've gone to 90 on the width, come down here, and we know that the answer is going to be 90 centimetres because of the units of the question. Okay, so that's an example of how to use y equals mx plus c in terms of straight line graph work with using ratios. Now we've got another question here which talks about a graph being given and you've got to find the equation for L. Well, the first thing we should recognise is that this is a straight line graph, and we should be thinking to ourselves straight line graphs means that the intercept value is going to be our C number and the gradient is going to be the change in the Y values divided by the change in the X values. So M is equal to the change in Y divided by the change in X. And we need 2 coordinates to allow us to do that. Now on this particular question they've given us a nice coordinate there because we've been told that the graph crosses the y-axis when x is 0 at -6, and we've been told that the graph crosses here. So we've got 2 coordinates, so this coordinate is 0, -6, and this coordinate is 2, 0, and because the gradient is equal to the change in the y coordinates divided by the change in the x coordinates, well, we can see that the change in the y coordinates, well, we've gone from 0 to -6, so that's going to be a change of 6, and we can see the change in the x coordinates, well, we've gone from 2 to 0, so the change in the x coordinates is 2, so our gradient is going to be 3. We can see that the intercept point is where the graph crosses the y-axis, so our C value is equal to -6, our M value is equal to 3, so the equation of this line is y equals 3x take away 6. Now we should check, because we want to work through the idea that we've done some work, we want to make it work, make sure it works. So if we choose this coordinate here, then when x equals 1, y will equal 3 lots of 1 take away 6. Well, that's going to be 3 take away 6, which is equal to -3. Well, when we look at our graph, we can see that this coordinate here is 1, -3. The x is the first value, the y is the second value. So our check worked and we can be happy days. Okay, so that's how we can find the equation of a straight line given. Now the exam questions could involve real life graphs, and we've got one here where it's telling us that we've got a graph and it's telling us the depth of the tank after 20 seconds. So it wants us to calculate the gradient of the graph. Okay, so it shows the graph depth of water after 20 seconds, calculate the gradient of the graph. Okay, so we take the graph and we recognise that the word gradient is important, and we recognise from our straight line work that the C value will be that. The gradient is going to be equal to the change in the y coordinates divided by the change in the x coordinates, and we need 2 points on the graph, so we can see that this graph has been drawn quite nicely because it wants us to work with this coordinate here, which is 190, so 0, 190, and this coordinate here is 140, 0. Wise to choose points that are as far apart as possible, and to choose points that have sensible coordinates to read off. Could have chosen that one because that one has nice coordinates as well, so there's lots of coordinates on this particular graph we could have chosen. So we know the gradient is equal to the change in the y coordinates divided by the change in the x coordinates. So in this case, the change in y, well, always look, this is a negative gradient. So our change in y means we've gone from 190 down to 0. So that's going to be negative 190. And our change in x, well, we're going positive on the x, so we've come down. So that's why we know it's going to be negative for y. And we've come across to the right, so we know it's going to be positive for x, so that's going to be 140. And when we calculate that, divide both of those by 10, we end up with negative 19/14. Okay, now whenever you do gradients of real life graphs, then you should really be thinking of the units. So this is centimetres for the y, and the x is seconds. So basically this is telling us that negative 19/14 centimetres per second. Now the negative means that it's decreasing, it's getting lower. So this question went on and asked you to explain what the gradient means. So basically we'd be saying to ourselves that the depth of water, because this was about depth of water, the depth of water is decreasing at a rate of negative 19/40. Don't need the negative because we've interpreted that by the word decreasing. So the depth of water is decreasing at a rate of 19/14 centimetres per second. Okay, now if you don't like working with fractions, because they do exist, then you could change that into a decimal, but that would give you an error in terms of you'd round it to so many decimal places, so it wouldn't be as accurate as using 19/14. Okay, so that's a reminder of how to calculate the gradient of straight line graphs using the delta y over delta x principle, changing the y coordinates, just remembering that if you're going in that direction it's going to be negative, and if you're going in that direction it'll be positive for the y. So here we have a negative y and here we have a positive y. Alright, the change. Okay, so just one last example. So we've got a diagram here, and it's telling us that a straight line is parallel to the one given, and it passes through the point 0,5. So a straight line and passes through the point 0,5. Okay, so we need to draw that point on, but we can't because it's not on the scale. So we just know it's going to go through 0,5. So we know that this graph is going to be parallel to this one, so it must go in the same direction, but it's going to cross at -5 on the y-axis when x is 0. So that's what that's telling us. It's parallel, which means has the same gradient. So basically that means we've got to calculate the gradient of this one, and so for L1, m equals the change in the y divided by the change in the x. So choose 2 points on the graph, so I'll choose that one, and there's another nice coordinate there. So this coordinate was 0, 2, and this coordinate was 4, 5, and what we can see is that the change in the y coordinates is 2. We've gone from 5 to 0, 3. Can't copy. So we've gone positives because we've gone up there. So it's positive 2. That's the change in y. So delta y equals 2. And along here we've gone across 3. So our delta x is equal to 3. So we know that delta y was 2, change in y, divided by delta x, which was 3. So our gradient is 2/3. We know the intercept point because of the coordinate they gave us. They told us that it passes through 0, -5. So from our y equals mx+c, we can now fill in all the bits we need. So for L2, y equals, well, our gradient was 2/3 of x, and our c value was -5. So if you add -5, you get to take away 5. So that would be the answer to that question. So we've got to find the equation of that line, and so forth. Okay, so Okay, so this one is find an equation of the straight line with a gradient 3 and passes through the point A. So, and passes through A. Alright, so it's got a gradient of 3. Now, what we've got to remember about a gradient, again, if we think to ourselves what we should know, then if we've got y equals mx plus c, the equation of all straight lines, then it must pass through some point C, and it's telling us it's got a gradient of 3. So our gradient is the change in y divided by the change in x. Well, if I keep this simple, and I say that the change in x is 1, then we know that 3 is equal to the change in y divided by 1. Well, that means that delta y must have been 3. So if I start with this point here, and I only change by 1, so on this scale I've gone across there, I had a change in y of 3. So that means I went to there. So basically, I know this graph is going to go through those two coordinates, and it's going to do that. And so now I've got this stage where I've drawn the graph. I've recognised that for one across I must have had a change of 3, because that's what the gradient can basically be thought of. For every one across on the scale you go up 3 in this case, because it's a positive gradient. If it was going in the opposite direction, so if you had something like this, then for every one across I'd have gone down something. So this would be a gradient of -2. So you'd get y equals -2x plus something. So now it said it wants you to find the equation of the straight line. Well, they already told us that it was 3 for the gradient. So thinking about mx, gradient times the x value, so 3x. And now from drawing the graph we can see that it's crossed the x-axis, sorry, the y-axis at -1. So therefore it'll be 3x take away 1. Now we should check that that worked. So if we take the coordinate that they gave us, the cross point, that was the coordinate of 2, 5. So we'll check 2, 5. So y is equal to 3 lots of 2, remembering that that's the x number and that's the y number. Take away 1, and 6 take away 1 is 5. And because the y value was 5, then our check has worked, and we're going to be quite happy we've done this correctly. So that's a run through of virtually all the types of questions you might get on the foundation papers up to grade 5 on straight line linear graphs.